Hey guys, Chemicals here with another chemistry video. Today we'll be doing Gases Galore 2, Equations, Laws, and more equations. This is part 2 of the 3-part series on gases. You're gonna need to see part 1 before this. So, actually you don't need to, but I'd recommend you do, but you don't have to. Anyway, this is just a video full of all the gas laws and equations except the ideal gas law. That gets its own video, which will be the third and final part of the 3-part series. So I'm going to go through like 5 or 6 laws here. We're just going to tell you what they are, do an example, and boom, move on to the next one so it's not like a 30-minute long video. Here we go. We'll start with Dalton's law of partial pressures. Here's the equation. P total, pressure total, equals pressure of element 1 plus pressure of element 2 plus pressure of element 3, element 4, element 5, blah, blah, blah. He represents that just by saying P of n. So if you have like 6 elements, it's equal to P1 plus P2 plus P3 plus P4 plus P5 plus P6. Instead of just writing all those out, he says to the Pn. Like I just said, P1's pressure of element 1, blah, blah, blah. So yeah, the pressures of all parts of the container equal the total pressure. Here's a little example. What is the total pressure of a combination of hydrogen gas and oxygen gas when they have a pressure of 1.7 atm and 0.3 atm respectively? Well, P total equals P1 plus P2. P total equals 1.7 plus 0.3. P total is 2.0 atm. That's it. Boyle's law. Okay, so who's this Boyle guy? This Boyle guy pretty much said at a constant temperature, the pressure of gas is dependent on the volume space of said gas. So at a constant temperature, so in the same room at the same temperature, the volume of a gas depends on the pressure being exerted on said gas, and that's what it means. So if you change the pressure of a gas, the volume will change too. That's essentially what it means. There's the summed up version. Change pressure, volume changes, which makes sense. P1 is initial pressure, V1 is initial volume, P2 final pressure, V2 final volume. Example: a balloon with a volume of 2.0 liters is filled with a gas of 3 atmospheres. If the pressure is reduced to 0.5 atmospheres without a change in temperature, what would be the volume of the balloon? So P1 times V1 equals P2 times V2. Plug in the givens. In this case, the givens were V1 right here, 2 is V1, P1, 3, P2, 0.5, and what we're trying to find is V2. So you plug in what they gave you, and you get this. Replace the desired with an x. 2 times 3 is 6. 0.5 times, well, V2, which we're going to make x, is x. So 6 equals 0.50x, and x represents V2. Isolate the x by dividing by 0.50, and you get 12 liters. The balloon would have a volume of 12 liters. Charles, baby. Charles, baby. Alright, so what did this Charles guy say? He's almost exactly like Boyle, except he said at a constant pressure, the volume of a gas will change if you change the temperature. So if you keep the pressure the same, if you keep pushing on the gas at the same strength, and you change the volume of the container, the temperature is going to change. Or if you change the temperature, the volume is going to change. So it's V1 over T1 equals V2 over T2, or V1 times T2, not T1, V1 times T2 equals V2 times T1. Notice that's backwards from Boyle's law, where it was P1 and V1 and P2 and V2. Charles is P2 and V1 and T2 and V2 and T1. Just make sure you know that. Okay, sample. A 600 milliliter sample of nitrogen is heated from 27 degrees Celsius to 77 degrees Celsius at a constant pressure. What is the final volume? So, you gotta have all temperatures in kelvins. For all gas laws, all the temperatures have got to be kelvins. We went over how to convert last time, but quick sum up, you add 273 to Celsius. If you didn't get that, check out the last video. So step 1, convert all the temperatures to kelvins. 27 degrees Celsius, you got to make it kelvins. 77 degrees Celsius, got to make it kelvins. So 27 degrees plus 273, 300 kelvins. 77 plus 273, 350 kelvins. And now, just like all other gas law equations, you just plug in what they gave you. What did they give us? They give us volume 1, temperature 2. We're trying to find volume 2. So V1 times T2 equals V2 times T1. So V1, 600. T2, not T1, T2, 350 equals V2 times T1, 300. Make sure you remember that T2 and V1 go together, not T2 and V2. Opposites in this case. The 2's go with the 1, not with each other. And the 1 goes with the 2, not with the 1. If that made any sense. So now I just like to replace V2 with an X for the desired. So then you get 600 times 350 equals 2100 equals 300x. Solve for x by dividing by 300. Your answer, 700 milliliters. So that's the answer. The final volume of the sample of nitrogen would be 700 milliliters. Okay, two left. Gay-Lussac's law. So what did these two guys say? Well, they pretty much said that, you know what? Let's just finish it. Let's finish it off. Boyle said there's a relationship between pressure and volume. Charles said there's a relationship between temperature and volume. So we're going to say there's a relationship between pressure and temperature. The three elements are all related, and Gay-Lussac deals with the pressure and the temperature. Boyle's deals with the pressure and the volume. Charles deals with the pressure, the volume, and the temperature. You didn't need to know that. Well, you do, but you don't. I'm rambling. Let's just get back to Gay-Lussac. So the equation P1 times T2 equals P2 times T1. Notice this is like Charles' law, where the 1 goes with the 2, and the 2 goes with the 1. Not the 1 with the 1 and the 2 with the 2. 1 with 2, 2 with 1. Remember that. Okay, sample. There's a 20-liter cylinder containing 6 atm of a gas at 27 degrees Celsius. What would the pressure of the gas be? What would the pressure of the gas be if the gas was heated to 77 degrees Celsius? Okay, P1 times T2 equals P2 times T1. As always, you gotta make all the temperatures Kelvin. We just did it for the last one, so same thing. Plug in the givens. Replace the desired with an X. Solve for X. 7.0 atm is the answer. I just kind of rushed through that because, well, it's just like Charles' law, but with pressure instead of volume, like I said here. Okay, so that's that. Now, why do we have all these separate equations? Why don't we just combine them all together to make one? Oh wait, we do. And that is the combined gas law. And that is P1 times V1 over T1 equals P2 times V2 over T2. That's what it is. P1 V1 over T1, P2 V2 over T2. Let's do a sample. A 30-liter cylinder contains gas at a pressure of 2 atm at a temperature of 420 Kelvin. Find the temperature of the gas, which has volume of 40 liters at a pressure of 3 atm. So there's the equation again. Plug in the givens. What do they give you here? They give you a V1, they give you P1, they give you T1. So you got this whole left side filled in. They give you all of that. They give you V2, and they give you P2. So you're looking for T2. It says find the temperature, T2. So you fill in everything but T2 based on what the problem gives you, and you get something that looks like this. Then, well, you do the math. 60, 2 times 30, 60 over 420 equals 3 times 40, 120 over x. You isolate for x by multiplying by x. So 60 over 420 equals 0.15. Multiply by x to get x on the other side. 0.14x equals 120, and divide by 0.14, you get 875, or 857, sorry. Here, let me just show you what I mean. 857. Kelvins is your answer, because all temperatures of these gas laws are Kelvin. Cool. I know I just rushed through a ton of stuff. I highly recommend that you visit my website, www.kamizo.blogs. That's it for this video. If you liked it, do me a favor and share it with anybody you think needs help on the subject. Once again, sorry for rushing through all the laws, but the website really does a much better job of explaining them. I recommend you check it out. See you guys next time.